Hi, and welcome to today's video. Today we're going to continue with our discussion of quadratics, and we're going to move on to the topic of factoring quadratic expressions. So first of all, just a reminder of what a factor is. A factor is a number that evenly divides a larger number. So for example, 2 is a factor of 6, because if you take 6 and divide it by 2, you get another whole number. You get 3 from that. So 3 is also a factor of 6 because when you take 6 and divide by 3, you get 2. Okay? Factoring is a method of breaking down polynomials into smaller factors. So later on when we get to higher order polynomials, we will talk about factoring those as well. But for quadratics, that's what we're going to be doing right now. So first of all, in the first example, factor each expression. So what we're going to do, we have this expression here, 2x cubed plus 6x squared minus 4x. So what I want you to notice here is that all of the terms have a factor of 2 in them, and they all have an x. So the greatest common factor of each of these terms is 2x. And so that's what we want to find the greatest common factor of all the terms and factor out that GCF. Okay, so since we have a GCF of 2x, we're going to bring it out front. We're going to factor it out. And so what we have to think about is if we're dividing this by 2x, remember up here when we said 2 is a factor of 6, well, 6 divided by 2 gives us 3. So since our factor is 2x now, we're going to divide 2x by each of these terms. So 2x cubed divided by 2x. Well, if we take 2 divided by 2, that's just 1, and x cubed divided by x is just x squared. Okay, our next term, if we divide this one by 2x, 6x squared divided by 2x is 3x. And negative 4x divided by 2x is just negative 2. Okay, so in our next example, B, 5z squared minus 15z. So again, we have to think about what is it that's the greatest common factor of all those terms, or what do they have in common in each? Well, notice they both have a factor of 5 in them, and they both have a factor of z. So we're going to factor out 5z. So that's our greatest common factor is 5z. So 5z times, we take 5z out of this one. 5z squared divided by 5z leaves us with just z left over. And if we factor out 5z from this one, negative 15z divided by 5z is just negative 3. Okay, so if it says find the greatest common factor and factor that out, that's what you're going to do. Okay, so here are just some reminders to help you out, some background information here. So when we multiply two binomials, remember we talked about doing that, and we use the FOIL method, first, outer, inner, and last. Okay, so here is just a reminder of when we're multiplying. So if we want to multiply x plus 2 times x plus 3, remember we take the first, x times x is x squared. The outer is x times 3, which is 3x. The inner is 2 times x, which is 2x. And then the last is 2 times 3, which is 6. And so we have the 3x plus the 2x, those two middle terms we combine into 5x. So x plus 2 and x plus 3 are linear factors of x squared plus 5x minus 6. So because these two things we're multiplying together, those are factors of this bigger polynomial here. Okay? So I want you to think about just kind of generic. If we can generalize things, it might help us to see what's going on here. So think about x plus m times x plus n. So when we FOIL that, we get, of course, x squared plus nx plus mx, and then, got to make the line there, m times n. So our ax squared plus bx plus c, I don't know why I put the x up there, bx plus c, is x squared plus, plus the quantity n plus m times x plus m times n. Okay, because we multiplied these and here we added them. So remember, when we have something, say 2x plus 3x, we just add the 2 and the 3 and keep the x. So that's what this is showing you here. Okay, so notice that b is equal to n plus m, and c is equal to n times n. So when factoring, what we need to think about is we need two factors of c that add up to b. Okay, so here is just a couple of examples with just some numbers that might help you to kind of start thinking in that direction. Find two factors of 12 that add up to, and we have several different numbers here. So first of all, the 7. Two factors of 12 that add up to 7. So ways that we could multiply together two numbers to get 12 might be, say, 2 times 6 or 3 times 4. So if we want them to multiply together to make 12, but add together to get 7, well, 3 times 4 is 12, and 3 plus 4 is 7. So that is our answer. 4 and 3 gives us 12, but when we add them, we get 7. Okay, so how about 8? Well, we just kind of talked about that one. 6 times 2. If we take 6 times 2, we get 12. If we take 6 plus 2, we get 8. So our answer here is 6 and 2. Okay, how about negative 13? Okay, so we could also think of this 12, two numbers that multiply together that make 12 could both be negative. They could be negative 1 and negative 12, for example. And negative 1 plus a negative 12 is negative 13. So in this case, we have negative 1 and negative 12. Okay, so moving on. We're going to start out with some more basic examples here. So we want to factor this expression here, x squared plus 5x plus 6. And we've maybe already kind of seen this one. We want to think of two factors of 6 that add up to 5. Well, two factors of 6 that add up to 5 would be 2 and 3. 2 times 3 is 6. 2 plus 3 is 5. Okay, so over here I have written all the ways that we could factor 6. 6 could be 1 times 6, or it could be 2 times 3. But 1 plus 6 is 7. That doesn't give us this middle term. So that's not the one that we want. We want the 2 and the 3. So when we're factoring, we just need, remember this is our first term in FOIL. So our x is going to go here and here because we want our first, when we multiply them together, to be x times x to give us the x squared. So that's why we have x and x. And then our last has to be our two numbers that multiply together to make 6. So 2 times 3 is 6. And when we take the outer and the inner, 3x plus 2x gives us the 5x. Okay, so hopefully that kind of helps you to see how this works. Next one, x squared plus 13x plus 12. So again, we need two factors of 12 that add up to 13. Well, that one's fairly easy, 12 and 1. So 12 times 1 is 12, 12 plus 1 is 13. So again, I didn't show all the steps this time, just trying to make it a little simpler. X times x is x squared, plus 1x plus 12x gives us that 13x, and 12 times 1 is 12. Okay, so maybe a little more complicated example now. Factoring when the middle term is negative. So if you think about this, for our middle term to be negative, we need two numbers that multiply together that are positive, but when they add together are negative. So they must both be negative in that case. So for the C term to be positive, the factors must both be positive or both be negative. So if this is positive and this is negative, both of our factors are going to be negative. If this is positive and this is positive, both of our factors are going to be positive. Okay, so we need two factors of 7 that add up to negative 8. Well, of course, negative 1 and negative 7 add up to negative 8. Negative 1 times negative 7 is positive 7. So it factors very nicely, just like that. Okay, in this next example, I'm going to show you factor by grouping. It's just a slightly different way of looking at it. So if you're a little bit confused by what we've done so far, maybe this will clear it up for you or give you another tool that you can use. So we have x squared minus 8x plus 16. So we need to think about positive 16, two factors of 16 that add up to negative 8. So that could be, well, I have all of them listed here. Negative 1 times negative 16. When we add those, we get negative 17. That's not that middle term there, so that doesn't work. How about negative 2 times negative 8? Well, negative 2 plus negative 8 is negative 10. That doesn't work either. How about negative 4 times negative 4? When we add those two, we do get negative 8, so that seems to work. So I'm going to rewrite this with this middle term expanded out here into minus 4x minus 4x. And I got these two numbers from right here. Those two that we found added together to make up that middle term right there. Okay, so we have x squared minus 4x plus 16. Okay, so we want to group these first two terms together and these last two terms together. Now, the one thing to be careful of here is this sign right here. Because this is minus, since we're putting parentheses around that, we're basically factoring out a negative sign from both of those terms. So for this to be negative here. So we need 4x minus 16 instead of plus 16. And you can check really easily, just redistribute this negative sign and see if we end up back where we started. So if we multiply through by negative 1, we get minus 4x plus 16, which is what we have up here. So I know we've done that correctly. Okay, so now that we have two separate groups, find the GCF of each group and factor that out. So here, between x squared and 4x, our GCF is x. So I took an x out front here, and when I factor that out, we have x minus 4 left over. And in this one, well, between 4x and negative 16, the greatest common factor is 4. So I brought a 4 out, and that leaves, if we divide this one by 4, we have just x. Dividing this one by 4, we have negative 4. So notice these two happen to be the same when we do that. So since we have two terms that we're subtracting with a negative sign in the middle, or a minus, and each of these have the same term, we can factor that term out front here. So all I've done is I've taken this x minus 4 and brought it out front, and then what is left over is x minus 4 to go into the other factor. So we have x minus 4 times x minus 4. Hopefully, you just saw down here that since it was minus 4 and minus 4, many of you probably jumped right to that, and that's fine. Okay, one quick thing to note, x minus 4 times x minus 4 can be rewritten as x minus 4 quantity squared, because these are the same terms, so we can rewrite it just like if it were x times x. We could rewrite it as x squared. Since both of these are the same, we can rewrite it as x minus 4 quantity squared. Okay, so there was example 3. Moving on here. Next one, factoring when the last term is negative. So now, everything we've talked about so far, this has been positive. But now in these examples, this is going to be a negative number. Okay, so for this to be negative, we need our outer and our inner. When we multiply two things together that are negative, one of them has to be positive and the other one has to be negative. Okay, so we need to find two terms that multiply together to make negative 15 that add up to positive 2. So I have listed different ways that we can factor negative 15 here. Negative 15 times 1, or negative 1 times 15, or negative 3 times 5, or negative 5 times 3. So all the possibilities, and I have added those together. And of course, negative 3 plus 5 is positive 2, which is what we want here. Okay, so our two terms are going to be, notice here's our negative 3, and here's our 5. So x minus 3 times x plus 5. And we're done. Talk about that. Next one, we have x squared minus 9. So notice that the b term is missing here. There is no something x in the middle. So for this to be missing, our b term must be 0x. So that means b is 0. So we want our sum to end up being 0. So I've listed factors of negative 9. Negative 9 times 1, negative 1 times 9, and negative 3 times 3. Well, negative 3 plus 3 is 0, so that's the one that we need right there. So we just write x minus 3 times x minus 3, and we're done. Okay, next one, x squared minus 12x minus 28. So 28 has a lot of different factors. Might be a little bit harder to think about two factors of negative 28 that add up to negative 12. Maybe not quite as easy. So if you've been able to do some of these in your head before, you may want to make a table on this one. So factors of 28, or ways that we can factor 28. 28 times 1, negative 28 times 1. Negative 1 times 28, negative 2 times 14, negative 14 times 2, negative 7 times 4, and negative 4 times 7. And I have all of the sums here. We want negative 12 in the middle, so it's going to be negative 14 times 2. So I have factored it here into x minus 14 times x plus 2, and we're done. Okay, so one more thing to talk about here, and that is when our a value is not equal to 1. So hopefully you've noticed so far, every example we have done, our a value has been 1. So just x squared, not 2x squared or 4x squared, it's just been x squared. So now we need some different tools for when our a value is not 1. So our first step, of course, we always want to look to do this, is factor the greatest common factor of all the terms. So if there's something we can take out first to help us make the number smaller, let's go ahead and do that. Okay, step 2, find factors of a times c that add up to b. So that's just like we did before, nothing new there. Using these two factors, expand the x term. So I did do an example of that earlier where I expanded the x term. We'll do a couple more like that here in just a second. Step 4, group the first two and last two terms together. And again, be careful of the sign inside that second group. So just like we did before, we're going to do that again. Step 5, factor the greatest common factor from each group. Step 6, factor the common term from both groups. And step 7, check by using FOIL. So we'll do a couple of examples of that here in just a second. So those are the steps that we are going to use for our next two examples. Okay, so example 5, factor. And our first one, a, is 4x squared minus 34x plus 60. So hopefully you notice on this one that since all of these terms are even, we have a common factor of 2 in all of them. So the first thing we want to do is factor of 2. So we're going to take 2 out of every term. So we have 2 times the quantity, 2x squared minus 17x plus 30. Okay, so far so good. Now we need to find a times c. Now remember, we aren't going to do anything more with this because we've already factored it out. So it's just going to hang out up front here. We're not going to touch it anymore. So our a times c is 2 times 30, which is 60. So we need two factors of 60 that add up to negative 17. So factors of 60. That's a bigger number. Might take you a few seconds to figure it out. But it does happen to be negative 5 times negative 12 is positive 60. Negative 5 plus a negative 12 is a negative 17 that we want. So we're going to expand out that middle term. So we're going to use these two numbers, negative 5 and negative 12, to expand out that middle term. So 17x becomes negative 5x minus 12x. And the other two terms just stay the same. Hopefully here you see that this is all of the numbers when we end up FOILing. 2x squared plus or minus 5x minus 12x plus 30. So if we were to FOIL this back out when we get our answer, we should have something that looks kind of like this. Okay, so step 4 was to group our terms together. So group the first two terms together, which is just right here. Group the second two terms together, which is right here. And remember, we have to be careful because this is negative. we have to change the sign here and make it negative also, because a negative times a negative is positive. Okay, so we've grouped this together, grouped this together, and so now we can go ahead and uh, factor out the greatest common factor from each term. So here, if we take the greatest common factor of these two terms, the greatest common factor is x. So we have x times the quantity 2x minus 5. And the greatest common factor of these two terms is 6. So we're going to take a 6 out of both of those. And we have, once again, 2x minus 5. So that's convenient. This is the same, and this is the same. So what we're going to do is we're going to factor that out from both terms. And what's left over is going to be just x minus 6 for our other term. So we have 2 times quantity 2x minus 5 times the quantity x minus 6. And if we were to multiply that all back together, we would end up back there. Okay, so last example, 6x squared minus 7x minus 5. So once again, look for a greatest common factor. Well, these two are both odd. They don't have anything in common. So there is no GCF to factor out. So if we look at A times C, 6 times negative 5 is negative 30. So we need two factors of negative 30 that add up to negative 7. So negative 30, well, that could be 6 and 5. That could be 15 and 2. Or it could be 10 and 3. Well, negative 10 times 3 is negative 30. And negative 10 plus 3 is negative 7. So that one seems to work. So once again, expand out that middle term. So we have plus 3x and minus 10x right here. So we have 6x squared plus 3x minus 10x minus 5. Okay, now we're going to group these two terms together and group these two terms together. So we have 6x squared plus 3x minus the quantity 10x plus 5. Okay, factor out the GCF from these two terms. Well, between 6x squared and 3x, the greatest common factor is 3x. And so that would leave us, if we divide this by 3x, we get 2x. If we divide 3x by 3x, we get 1. So we end up with 3x times the quantity 2x plus 1. And same thing here, we're going to take out between 10x and 5. It's like 5. So we factor out a 5, 5 times the quantity 2x plus 1. Okay, so now notice we have 2x plus 1 in both of them. So I factor that out to the front here, leaving us with just 3x minus 5. Okay, so I know we've done a lot of examples today. Hopefully that helps you out when you start factoring on your own. And if you've taken good notes, hopefully these tools will help you out. So thank you once again for joining me, and I'm sure that we'll be seeing each other again soon. Have a great night.